In this video, we'll be looking at the unit circle and trig functions, often called circular functions when we talk about them in conjunction with the unit circle. Now basically, a unit circle is a circle with a radius of 1 unit. So on our diagram here, you'll see that the radius, which is also the hypotenuse of the right triangle we have there, is 1. So the radius is 1, and the x value and the y value are just the coordinates of the point at the end of the radius. Now recall our definitions for our trig functions. Sine is y over r, cosine x over r, and so forth. Now when we look at those trig functions in conjunction with the unit circle, the r value is now equal to 1, because remember before the r was this distance from the center of the circle out to the point. So when r is 1, my sine function just becomes y over 1, which is just y. Cosine is x over 1, which is just x. Tangent is still y over x. My cosecant now, the reciprocal of sine, is 1 over y. My secant is 1 over x. My cotangent is x over y. So the trig functions don't change. The only thing that changes when you talk about circular functions is the fact that r is now equal to 1. Now let's do some problems. We're asked to find the exact value of each circular function. My first one is sine of negative 3 pi. Now we know that the sine of theta is y when we deal with circular functions. And so this problem, if we want to look at the sketch, negative 3 pi, a negative angle, you have to go clockwise starting from the positive x-axis. So this is 1 pi, just this lower semicircle. So there's 1 pi, and then 2 pi, and then 3 pi. So a negative 3 pi puts me over here on the unit circle, so the distance from the center out to the circle is 1 unit. And the coordinates then of that point are negative 1, 0. Since sine is defined to be equal to y, then my sine of negative 3 pi is 0. Now we'll use the same sketch to do this next one. Since my argument is still negative 3 pi, this time I want the cosine. Well, cosine, when we're talking about circular functions, is just equal to x. And my x-coordinate on this point is negative 1. So the cosine of negative 3 pi is negative 1. Next one also uses the same diagram. We want the tangent of negative 3 pi. Tangent is still y over x. And so we want the y-coordinate over the x-coordinate. And so this one will be the tangent of negative 3 pi is 0 over negative 1, which is 0. Now in this example, we're asked to find the exact value for each circular function. Now notice on the sketch, I have argument, my angle is 4 pi over 3. Since the denominator is 3, that means we're dealing with, in degrees, a 60-degree reference angle. But 4 pi over 3, this top semicircle is pi, or 3 pi over 3. And so 4 pi over 3 puts me down in quadrant 3. Since we know, though, that it's a 60-degree reference angle, or pi over 3, then we know that the sides are going to be, the side opposite is root 3 and negative because it's down. The side adjacent is 1, and it'll be negative because it's to the left. And then my hypotenuse is 2. Now this is the ratios that we've learned in the past. All right, for circular functions, all we do is divide each of these sides by 2. So my hypotenuse, which is the radius of my unit circle now, is going to be 1. When I divide here by 2, I get negative 1/2. And I divide here by 2, I get a negative root 3 over 2. So in black is the side ratios, or side lengths, that we've learned in the past for our special 30, 60, 90 triangle. And in red is what they would be if it was a unit circle. Now, because I did a circular function, we know that the sine is defined as just y, the y value. And so the y value on this sketch is my negative root 3 over 2. So my answer is negative root 3 over 2. Now my next problem uses the same sketch. We're asked to find the cosine of 4 pi over 3. Notice again the argument of my trig function is still 4 pi over 3. So my side ratios are written this way, and cosine is just defined to be the x value for a unit circle, and so negative 1/2. Now you might be wondering why I used both of these. Some students feel more comfortable using the unit circle definition, and some students feel more comfortable using the side lengths that they've already learned. Either one will work. For example, up in here, when we notice that 4 pi over 3 is a 60-degree reference angle, and we put these black measurements in, then sine is opposite over hypotenuse, which is just negative root 3 over 2. So using the unit circle definition or our special triangles ratios, either way is fine. They'll both get you the correct measurement. On our next one, we're asked to find the tangent of negative pi over 4. Now, pi over 4, when the denominator is 4, we're dealing with the 45-45 right triangle, reference triangle, and this is a negative 9 pi over 4. So our drawing, we need to go in the clockwise direction. 4 pi over 4, or I'm sorry, negative 4 pi over 4 will be this one semicircle. So there's negative 4 pi over 4, and then another one will give me a negative 8 pi over 4, and then another 1 pi over 4 will put me at negative 9 pi over 4. So my reference triangle is drawn in quadrant 4, and in black you'll notice again I put the 1, 1, root 2, which is what we've learned from the past special triangles. Notice this one is positive because it's to the right, and then negative because it's going down. Now if we use our unit circle for the side lengths, dividing by root 2 on all of them, this will be 1, And then this one is 1 divided by root 2. If we rationalize the denominator by multiplying top and bottom by root 2, we get root 2 over 2. And same way here, negative root 2 over 2. So my tangent is defined as y over x. It's simpler to think of these black measurements, negative 1 over 1, but we can also use the negative root 2 over 2 over root 2 over 2, and that also gives you 1. And then on this one, our denominator is 6, so we're dealing with a 30-degree reference angle. If it's positive, so the top semicircle is 6 pi over 6. And then another 5 pi over 6 puts me over in quadrant 4. Now the way I like to think of it also sometimes is to go with the whole circle is 12 pi over 6. And then back it off 1 pi over 6. So either way we have a 30-degree reference angle. Side opposite is 1, side adjacent is root 3, and the hypotenuse is 2. Now again, if we look at the unit circle, divide all of these by 2, so my hypotenuse is 1, root 3 over 2 here, and a negative 1 over 2 here. Sine is defined as the y value, so negative 1/2. On this one, we're asked to use a calculator and find an approximation for each circular function. So we'll need to get our calculator out. Now whenever you do a trig function, the argument is an angle. So this angle is in radians. Remember, if it has no unit measure on it, it has no degree mark on it, then that means it's in radians. Right now, my calculator is in degree mode. The little DEG right here indicates degree mode. So I need to change my mode, and usually what I'll look for is a DRG button, which in this calculator is right here, or you might need to go to your mode. The DRG stands for degrees, radians, grads. And if I push that, you can see right now degree mode is selected. So I need to move over and select the radian mode and press enter, and now you'll see right here in the screen that I have RAD showing. Always, always, always make sure your calculator's in radian mode when you deal with trig functions of radian measures. Now to do our sine, we just do it as normal. Sine of 3.42 and looks like negative 0.2748. And our next one, always check, make sure you're in radians. I need tangent of 0.8234 and looks like 1.0790. My next one, this is a reciprocal function. So before you can put anything into your calculator, you need to use your definition of reciprocals. Remember that secant is the reciprocal of cosine. So secant of theta is equal to 1 over cosine theta. So I'll write then secant of 5.6041, which is what I'm looking for, is equal to 1 over the cosine of that angle. So to do this on my calculator, I need 1 divided by the cosine of 5.6041 and 1.2851. My next one, this is also a reciprocal function. We know that cosecant is the reciprocal of sine. So cosecant is equal to 1 over the sine. So that means that my cosecant of this angle is going to equal 1 over the sine of the same angle. Now that I'm in sine, I can do the calculation. 1 divided by sine negative 2.7335. And I get negative 2.51978. Usually we take it to 4 decimals, which means that I'll take this up to an 8. 2.5198. Now in this example, we're asked to approximate the value of s in the closed interval from 0 to pi over 2 if the sine of s is 0.3210. Now, by looking at the problem, we can see that since I have the sine of s, that means s is going to be an angle. Since my interval is from 0 to pi over 2, my angle needs to be in radians. Okay, this is my domain. Right. So to find s, we need to inverse sine both sides of this equation because it wants the approximate value, so I'm going to just use a calculator. To get s by itself here, I do an inverse sine on both sides. When I do that, the inverse sine and the sine cancel each other off, and I get s equals inverse sine 0.3210. Now I can do that math. Inverse sine we get by taking second sine, and then 0.3210. And it looks like my angle measure is 0.3268. Remember, we're dealing in radians. Alright, my next one, I want to find the exact value of s in this interval, closed interval from 3 pi over 2 to 2 pi. So this interval indicates quadrant 4. And we're told that the tangent of s is negative root 3 over 3. Right, so we know from our interval that we're in quadrant 4. We also need to it helps if we take this ratio, this tangent ratio, and rationalize the numerator or unrationalize the denominator, however you want to think about it. But we're going to multiply top and bottom by root 3. When we do that, in the numerator we get negative 3. In the denominator we get 3 root 3. The 3's cancel. So this problem is the same as saying my tangent of s is a negative 1 over root 3. Since tangent is defined as opposite over adjacent, then the negative 1 is my opposite side and my root 3 is my adjacent side. So my reference angle is pi over 6, which we know is 30 degrees, obviously. But the pi over 6 is what we want to use because we have to give our answer in this interval. So the pi over 6 reference angle means that I'm going to be all the way around 2 pi and then back it off or subtract pi over 6. So 2 pi subtract 1 pi over 6 gives me 11 pi over 6.